Okay, so there are a few different types of number that we've been coming across that I've subtly been showing you. There are whole numbers and there are numbers with some decimal information. So the whole numbers we call integers. If you, an integer can be negative, it can be positive, it can be very large or very small. Don't be tempted to put a comma separating your hundreds and thousands or whatever notation you're used to. If you do that, Python will interpret this as a 13 and a 0 in a tuple, in a little two-element list, and it will get very confused. So just write your number as one long number with no spacing and no separators between your numbers. For decimal information, you can also define numbers that are large using scientific notation. So if you do 2e to the 4, it's going to do 2 times 10 to the 4. 2e to the minus 2 is going to do 2 times 10 to the minus 2. So this bottom line, 2e to the minus 2, is the same as writing 2 multiplied by 10 to the power of minus 2. And we remember that to the power is this double star sign. So those last two lines achieve the same thing, one using the scientific notation and one using the longhand with a multiplication and a power. Any questions about the way that works? Fantastic. Okay, so when you have numbers in Python, there's a lot of basic things you can do with them, things that in other languages might require a little more coding. If you want to find out the minimum value of a list of numbers, you can do it like this. You just type min, and then in brackets, give all your numbers separated by a comma, and the minimum one will be returned. Max does what you might expect, returns the maximum value of a bunch of numbers. So for our list, it's going to return 8. Abs will return the absolute value of a number. So if you don't care about the sign of the number, the positive and negative, you can use abs. That's useful for when you're looking at the magnitude of expression changes of a gene or something. You might not care about the sign of the number. Now, I spoke a little bit about converting things to floats when you want to do a division and you want to make sure you've got decimal place information. So you can check what type of variable Python is storing using this type command. So if you store a number and you want to make sure that it's a float, you can check using type. So if you type type, and then in brackets give it a variable, it will tell you what Python has stored that variable as. So if we check the type of -10, it's going to say that that's an integer, meaning it's stored it as a whole number, it's not stored any decimal place information. If I check the type of -10.4, it's telling me now that it's stored it as a float. So it does have some decimal place information there. That under the hood, behind the scenes, will mean that it's using more memory, that it might be a little slower if you do lots of processing, but it does mean that you can safely do things like division with it without losing information. And then you can convert things from one type to another, as we saw previously. So previously I showed you the float, that I can convert this whole integer 5 into a float. Well, here I can convert the number -10 into a string. String is text, is words, is letters, and then check the type of it, and it's stored as a string. So when you see these functions that look a little complicated, work from the innermost brackets outwards, and from these inner brackets you can see that we have a -10, that I'm then using str, which is how you convert something into a string, and then as I keep moving outwards, I find that I'm checking the type of that, and now I see that it's a string. That might seem a little weird, but what it means is rather than storing that as the number -10 to do maths with, to be able to add to other numbers and multiply, it's now stored as the minus letter, the 1 letter, and the 0 letter, like any other word. So we can do things like print it to a file now, or print it to the screen and concatenate it with other strings. So now it's a different data type. It's been changed from a number to a string, and Python will do that conversion for you. You might find sometimes you get an error when you try and do these conversions if it's unable to convert from one data type to the other. But you can certainly convert from numbers to strings fairly easily, and we'll be needing to do that a fair bit. Everyone follow so far? Great. Okay, so you'll notice that I've been putting double quotes around my strings, But you'll also notice that when Python shows me those strings back, sometimes it puts single quotes around them. So the question arises, since both seem to work, double quotes and single quotes, which is correct? And the answer is neither is correct, both work perfectly fine. Python, there was a release at some point because of pressure from the programming community to figure out which was the right one to use, and Python just said they're both the same and refused to take a side. So use whichever you want. There are tricks that you can do, such as putting single quotes within double quotes, but I would try and avoid that, and I'd try and be consistent. So as you can see here, these double quotes are exactly the same as writing these single quotes here. You can sometimes put symbols in your strings, and Python will attempt to figure it out. So here you'll see that it's, converted some of these symbols to character codes, but it's not caused an error. However, if you try and put a quote in your string, you might come across a problem. So here I'm saying, what's the deal with quotes in text? But what Python is seeing is that I've opened a quote, I've typed what, I've closed the quote, and then it thinks that the S is Python code, it thinks the is Python code, and it's falling over and failing to interpret all that as valid Python commands. So we get an error back. The way around that is to use what's called an escape character. So if you want to put a quote within a string, we put a backslash before the quote, and that tells Python that this next quote that's coming up is not Python code. I don't want you to interpret it as the end of the string. I want it to be part of the words that I'm putting in. So now I can type, that's better, but before the apostrophe, put a backslash, and then Python will accept the string perfectly fine. You'll notice that when Python prints it back to the screen, what it's done is it's put double quotes around the outside and single quotes on the inside, and that reveals that there is a trick you can do where if you define a string with double quotes, you can put single quotes inside it and Python won't have a problem. I personally think that's can get confusing, and you're probably better to make sure to clearly put an escape character before every quote within a string, just to be consistent and just so that everyone that looks at your code with any font they're using in any environment they're using can easily see that this character within my string is not meant to be the end of my string. So I would get into the habit of using escape characters rather than trying to mix these double and single quotes. Everyone follow? Any questions? Awesome. Okay, so there's some also useful functions inbuilt into Python for when you're working with strings. The in keyword will simply check whether one string is within another string. So is the substring TATA in the larger string TATATA? It is, so we get a true back. Note the capital T and lowercase RUE. If we then check for a string that isn't in there, for example, the two letters A in a row, within this sequence, we find false, that it is not in there. Remember capital F for false. We can then add the word not, which will negate the logic. So is AA not in TATATA? Well, it is not in there, so you get a true back. Rather than the false that you would get without the not, it negates that statement, and then we get a true back. You can glue strings together with the plus sign. We previously saw the plus sign for adding numbers together. So we did 7 plus 4 and we got 11. But if you do a string plus another string, you actually just concatenate the strings. You glue the end of one to the beginning of the next, and you get one single string back where the two strings are combined into one. And you can do this with lots and lots of strings in a row, just multiple plus symbols between all these strings. So that's why you have to be careful with the data type you're working with. If you think you're working with a number and you think you're doing mathematics, you might actually just be gluing strings together because you've got a string data type rather than a float data type, for example. So it's always important to check the type of your variable because the plus sign does different things to strings than it does for numbers. But for strings, it's fairly simple. It will glue your strings together. Any questions about that? So another thing that often catches people out is that if you're working with a string, you can still do multiplication on that string, but rather than doing any sensible mathematics, what it's going to do is concatenate the string together with itself a certain number of times. So if I do a string and I multiply it by 6, all I get is 6 repeats of that string. And you'll often find people trying to read numbers in from a file, not realizing they've got a string data type, trying to do some maths on it, and they end up with just the same number repeated a bunch of times rather than having any maths having happened. So it doesn't matter which side of the string you put the multiplication on. If you multiply a string, it's just going to repeat that string. That can be useful for defining a sequence or defining column headings or whatever, but often it's just a gotcha that catches people out. Now, strings of letters in Python, I want you to start thinking of a bit like lists of letters. So we're going to come across the list data type in a moment, but a lot of what applies to lists applies to strings, and a lot of what applies to strings applies to lists. So if I have a variable called myString, and it's equal to the letters Python, note I've got them in quotes because I'm defining a string here, I can then get the first letter from my string, the variable called myString, using this notation. I type the variable name, and then in square brackets I give the index I want to access. And in Python, we start counting at 0. So the string Python has the index 0 below the P, 1 for the Y, 2, 3, 4, 5. So if we want to get the letter at index 0, we simply put the 0 in those square brackets and P is returned. If we want the letter at index 1, put a 1 in the square brackets and the Y is returned. 5 gives us the N. And if we want to get beyond that, if we try and get a number 6, you'll find you'll get an error back telling you that the index is out of range. So we know we've gone too far at that point. So it's important to be aware that although there are 6 letters in Python, you can't get the index 6 because you can't start counting at 0. There's a method called len, which will tell you how long the string is. So the len of my string is 6 because there are 6 elements in my string. But be careful, you can't get the element at number 6. So don't use len to get the last index unless you take one away from it. But I'll show you there are better ways of getting the end of a string in a second. Okay. So as we saw, 0 is going to give us the P, but there are a couple of tricks to get the other letters. So you can use -1 to get the last letter of a string. So if you do myString, you do -1. What it actually does is it loops back around. It gives you -1, -2, -3, -4, etc. So rather than having to get the length of the string and taking one away from it to get the last letter, you can just get the element at index -1. The element at index -5 is going to be this Y, because we've gone all the way back around. And then what you can also do is get multiple letters at once. So if you specify one number, colon, another number, it's going to get all the letters between those indexes. Now you'll note that it's actually inclusive of the first index, but not including the second index. So if you do 1 to 4, it includes the element at index 1, so that Y is returned. You get 2, you get 3, you don't get the element at index 4. So whenever you see this colon notation with an index, a colon, another index, it's always going to include the element at the first index and go up to, but not include the element at the second index. So be careful with that. Everyone see how my string 1:4 is going to return YTH? Awesome. Okay, a couple of other things that are useful. If I have a sequence defined as AGCT, I can check the length of the sequence as we saw. I can convert it from upper to lower case, which is often useful if you're doing nucleotides and you don't care about this information. You can do seek.lower and then give some empty brackets to tell Python that this is a function we're running, and it will give you the sequence as a lowercase. Seek.upper will convert the sequence to an uppercase. So this dot notation we'll see a few times. It's a way of running a function, upper and lower are both functions, on a variable. So our variable is called seek, we define it up here, and we want to run the lower function on it or the upper function on it. As I showed before, you can concatenate things with the plus symbol, and the final line that's interesting is that you can use .count to tell you how often a substring appears in a larger string. This is useful when you're looking for nucleotide enrichment or counting GC content or something. If you do seq.countA, it's going to tell me how many times A appears in my sequence. Note that the sequence is AGCT, so A occurs once. Okay? So this is my sequence, AGCT, seq.countA will be 1. We can do .find, which will tell us the first index that a variable occurs in. So if we look for C in our sequence, seq.find C will tell us that the first C occurs at the index 2, because it doesn't occur at index 0 or 1, but it does occur at index 2. So if you want to find out where a substring first occurs in a larger string, you may be looking for a binding sequence or something, you can use seq.find and it will tell you the index where that substring first occurs. So the C in our sequence doesn't occur at A, which is 0, it doesn't occur at G, which is 1, it does occur at C, which is 2, so we get 2 back. Seq.startsWith will tell us whether our sequence variable starts with a certain substring. So does our sequence start with AG? Yes, it does, so true is returned. Does our sequence start with GC? No, it doesn't, so false is returned. But there is also an optional second argument that you can pass into starts with. If we do seq.starts with GC, we can give it an offset of 1, and it will begin counting 1 index in, rather than looking at the very first one. This is useful because often these FASTQ files or other big data files from next generation sequencing experiments have certain identifiers at the start of each line. And it's often not sequence information. You don't care about this if you're looking through the actual nucleotides. So you might use the starts with an offset of 1 to avoid that extra character at the start of the line. Or you might be loading a text file where the first column just gives an index and you don't want to worry about it. So we can use this seq.starts with GC with an offset of 1, so it ignores the first one, it starts looking here, and it says, yes, it does start with GC if I ignore the first letter. So that returns true. Everyone see why that last one is giving true? Anyone lost yet? Okay, great. Okay, so here's one that, if you're working with Python 3, might be a little different, but there is a Python 3 version of this. The raw input command is useful for getting text from whoever's running your program. So, for example, you might write a program to go to a database and look up a gene, and you might give the code to everyone in your lab, and they might run it, and when they run it, it might say, what gene are you looking for? And they type into the console the name of the gene they're looking for, and it will take that typing, save it as a variable, and do something with it. So if you want to ask whoever's running your code a question and save their answer as a variable, you can use this raw input command. So if I do name equals the result of raw input when I ask the question, what is your name? Close the quotes, close the brackets. Once you hit enter, you'll see what is your name printed to the screen. So whatever question you typed in the quote will be printed to the screen, and then the cursor will be sitting there waiting at the end of the line after the question mark. So then you can type the answer and hit enter, and it will look like nothing has changed. So let me just show you what I mean. If I check the variable name, oops, I'm not even in Python. So if I check the variable name, can't find it. But if I do name equals raw input, what is my name? It's going to ask me what my name is. I can type Simon, hit enter. Nothing seems to have happened. There's no result printed to the screen. But if I check the value of the name variable now, it's storing that text that I typed in before. So the Simon is stored in the variable name that I gave on the left of the equal sign. So here we can do the same. It asks what your name is, type the name, then we can use that name variable in whatever code we do next. So the next thing I want to show you is how to substitute variables into print statements. We're going to use this a lot. This forms the foundation of printing to text files. This forms the foundation of lots of creating output in Python in general. So we've seen the print statement before when we did hello world. All we did was open the brackets, open the quotes, and type hello world. We're going to do something very similar, but with a couple of tweaks, a couple of changes. I'm going to print your name is, and then a %s sign, and then I'm going to close the quotes, have one more % sign, and then some variable name. And the way Python sees that is that it wants to print your name is, and then some string. And what string does it want to substitute in there? Well, it wants to substitute in the name variable. So to substitute variables into a print statement, you use this notation. You first put a %s in your print statement where you want the string to be substituted in, and then after one more % sign, you put the actual variable that you want to substitute in. So when we run this, what you'll see is your name is Simon, because it's gone your name is some string and substituted in the name variable into that string. So whatever you answered your question with should be printed back to the screen. You can put brackets around this second variable, and that will become important when we're doing multiple substitutions. So let's define one more string. Let's define a variable called lang equal to the string Python. Remember, variable name on the left of an equal sign equals, and then in quotes, the actual value. Then I can do print my name is some string, and I use some other string. So now we have two strings we want to substitute in. What do we want to actually substitute in? Well, we want to substitute in the name variable and then the lang variable. The order that you give these variables in is the order that they will be substituted in to the %s's. So it's going to do my name is some string and I use some string, and it's going to substitute in name into the first position and lang into the second position. So you will get my name is Simon and I use Python.